Hello guys, you are welcome back to the reaction zone. In today's lesson, we're going to look at P block elements. P block elements are elements in which their last electron enters into the P subshell of the outermost electron shell. P block elements have valence shell electronic configuration that ranges from NS2 MP1 to NS2 MP6. What this means is that the valence electrons of P block elements ranges from 3 to 8. Members of this block of elements include some metals, all non-metals, as well as metalloids. Now we're going to look at the general characteristics of P block elements. The first is that it consists of 6 groups. P block elements comprise elements of group 13, group 14, group 15, group 16, group 17, as well as group 18. If you count the number of groups, you discover that there are 6. Members of this block generally show covalency. However, the highly electronegative members such as fluorine, chlorine, and nitrogen do not show covalency. Instead, what they show is electrovalency. Now, as you move from left to right across a period of P block elements, there is an increase in non-metallic character, which means to the left of a period of P block elements, you find metals. Towards the middle, you find metalloids and some non-metals. And to the extreme right, you find non-metals. So, non-metallic character increases across a period of P block elements as you move from left to right. Also, as you move from left to right across a period of P block elements, there is a reduction in the reducing nature. So, reducing nature of P block elements decreases as you move from left to right across a period of P block elements. But oxidizing nature of P block elements increases as you move from left to right across a period of P block elements. And this explains why elements of group 17 such as fluorine and chlorine are strong oxidizing agents. Also, P block elements do not impart a characteristic color to the flame, which means when you subject P block elements to the flame test, they don't show any color. Also, some members of P block elements exhibit allotropy. Allotropy is the existence of an element in 2 or more different forms in the physical state. Examples of P block elements that exhibit or show allotropy are carbon, silicon, germanium, phosphorus, boron, sulfur. These are examples of P block elements that exhibit allotropy. Carbon, for instance, has 2 allotropes, diamond and graphite. The allotropes of sulfur include rhombic sulfur, monoclinic sulfur, as well as amorphous sulfur. Also, many elements of the P block show catenation. Catenation is the ability of an element to form chains or rings in which its atoms are bonded together. Examples of P block elements that show catenation are carbon, silicon, germanium, sulfur, nitrogen, and oxygen. However, it is important to state that the degrees to which these elements show catenation vary. They are not the same. I want to believe that the general characteristics of P-block elements is clear from this explanation of mine. Thank you very much for viewing, and see you in the next lesson.